Today's lecture is a quiet collection of 50 facts about space. We will move through them slowly. 1. Space is not completely empty. When people use the word space, they often imagine a perfect vacuum. But space still contains particles, radiation, magnetic fields, dust, gas, and occasional larger objects. Compared with the air near Earth's surface, it is extremely empty. But it is not absolute nothingness. 2. A light year is a unit of distance, not a unit of time. It describes the distance that light travels in 1 year through a vacuum. Because light travels very quickly, a light year is an extremely large distance. Astronomers use light years because ordinary units, such as kilometers, become inconvenient when discussing stars and galaxies. 3. Light from the Sun takes about 8 minutes and 20 seconds to reach Earth. This means that when we look at the Sun, we are not seeing it exactly as it is at this instant. We are seeing it as it was a little more than 8 minutes ago. This is true for all distant objects in space. Looking outward into space is also looking slightly backward in time. 4. The Moon is on average about 384,400 kilometers from Earth. This distance changes slightly because the Moon's orbit is not a perfect circle. Sometimes the Moon is closer to Earth, and sometimes it is farther away. These differences affect its apparent size in the sky, though usually not in a very dramatic way. 5. The Moon is slowly moving away from Earth. Measurements show that the Moon recedes from Earth by a few centimeters per year. This happens because of tidal interactions between Earth and the Moon. Over very long timescales, these small changes become significant, although on the scale of a human lifetime, the effect is extremely small. 6. Earth's tides are caused mainly by the gravity of the Moon, with help from the Sun. The Moon's gravitational pull creates tidal bulges in Earth's oceans. The Sun also contributes to tides, though its effect is smaller than the Moon's because it is much farther away. When the Sun, Moon, and Earth line up, tides can be stronger. When they are at right angles, tides can be weaker. 7. There is no sharp physical boundary where Earth's atmosphere suddenly ends and space begins. The atmosphere becomes thinner and thinner with altitude. For practical purposes, the Kármán line, often placed around 100 kilometers above sea level, is used as a conventional boundary of space. But nature itself does not place a hard wall there. 8. The International Space Station orbits Earth at an altitude of roughly 400 kilometers. This is close to Earth compared with the size of the planet and very close compared with the distance to the Moon. Astronauts on the station are not far out in deep space. They are in low Earth orbit, still within the outer layers of Earth's extended atmosphere. 9. Astronauts on the International Space Station experience microgravity, not because gravity is absent, but because they are falling around Earth. Gravity at the altitude of the station is still fairly strong. The station and everything inside it are continuously falling toward Earth, but because they also move forward very quickly, they keep missing the ground. This creates the condition we call orbit. 10. The International Space Station completes one orbit of Earth in about 90 minutes. This means astronauts on board can experience many sunrises and sunsets in a single Earth day. The station moves very quickly at around 28,000 kilometers per hour. This speed is necessary to remain in orbit. 11. The Sun contains more than 99% of the mass of the entire solar system. The planets, moons, asteroids, comets, and dust all make up only a small remaining fraction. This is why the Sun dominates the gravitational structure of the solar system. The planets orbit the Sun because the Sun is by far the most massive object nearby. 12. The Sun is a star. It appears different from other stars because it is much closer to Earth. Other stars are also suns in the general sense. Large, hot spheres of plasma that produce energy through nuclear fusion. The Sun is ordinary in some ways, but to Earth it is the central source of light and heat. 13. The Sun produces energy through nuclear fusion in its core. In this process, hydrogen nuclei combine to form helium. A small amount of mass is converted into energy. This energy slowly makes its way outward through the Sun and eventually escapes into space as light and other forms of radiation. 14. The planets do not move in perfect circles. Their orbits are ellipses, although many planetary orbits in the solar system are close to circular. An ellipse is like a slightly stretched circle. Because of this shape, a planet's distance from the Sun changes somewhat during its orbit. 15. Mercury is the closest planet to the Sun, but it is not the hottest planet. Venus is hotter on average because it has a thick atmosphere rich in carbon dioxide, which traps heat very effectively. Mercury has almost no atmosphere to retain heat, so its surface temperatures change greatly between day and night. 16. Venus rotates very slowly. One rotation of Venus takes longer than one orbit around the Sun. This means that a day on Venus, in the sense of one full rotation, is longer than a Venusian year. Venus also rotates in the opposite direction from most planets in the solar system. 17. Mars has the largest volcano known in the solar system. It is called Olympus Mons. It is much larger than any volcano on Earth. Its great size is partly related to Mars having lower gravity and a different geological history from Earth. Mars does not have active plate tectonics in the same way Earth does. 18. Mars once had liquid water on its surface. Evidence from valleys, minerals, ancient lake beds, and sedimentary features suggest that water flowed on Mars in the distant past. Today, most water on Mars exists as ice or in minerals, and the surface is generally cold and dry. 19. Jupiter is the largest planet in the solar system. It is a gas giant, composed mostly of hydrogen and helium. Jupiter is so massive that it strongly influences the orbits of many smaller bodies. It also has a large family of moons and a powerful magnetic field. 20. Jupiter's Great Red Spot is a long-lasting storm. It has been observed for centuries, although its size and shape have changed over time. It is a large atmospheric system, much wider than Earth. Like many features on giant planets, it is driven by complex fluid motion in the atmosphere. 21. Saturn is not the only planet with rings. Jupiter, Uranus, and Neptune also have ring systems. Saturn's rings are simply the largest and most visible from Earth. Planetary rings are made of many small particles, mostly ice and rock, orbiting around the planet. 22. Saturn's rings are very wide but very thin. They extend across a large distance, but their vertical thickness is small compared with their width. The rings are not solid sheets. They are made of countless individual particles, each following its own orbit around Saturn. 23. Uranus rotates on its side. Its axis is tilted by about 98 degrees. This means that its seasons are very unusual compared with Earth's. For part of its orbit, one pole receives long periods of sunlight while the other remains in darkness. 24. Neptune is the farthest known major planet from the Sun. It is a cold ice giant with powerful winds and a deep blue appearance caused mainly by methane in its atmosphere. Neptune was discovered through mathematical prediction before it was directly observed. because its gravity affected the motion of Uranus. 25. Pluto is classified as a dwarf planet. It was once considered the 9th planet, but its classification changed as astronomers discovered more objects in the outer solar system. Pluto is still an important and interesting world, with mountains, plains, ice, and a thin atmosphere that changes with its distance from the Sun. 26. The asteroid belt lies mainly between Mars and Jupiter. It contains many rocky bodies, but it is not packed with objects like a dense field in science fiction. The distances between asteroids are usually very large. A spacecraft can pass through the asteroid belt without constantly dodging rocks. 27. Comets are made mostly of ice, dust, and rocky material. When a comet approaches the Sun, some of its ice turns into gas. This gas and dust can form a glowing coma and tails. The tails point generally away from the Sun because of solar radiation and the solar wind. 28. A meteor, a meteoroid, and a meteorite are not exactly the same thing. A meteoroid is a small object in space. A meteor is the bright streak seen when such an object enters an atmosphere and burns. A meteorite is a piece that survives the passage through the atmosphere and reaches the ground. 29. Most meteors are caused by very small particles. Many are no larger than grains of sand or small pebbles. They appear bright because they enter the atmosphere at high speeds and heat the air around them. The visible streak is not usually the object itself glowing like a coal, but the heated air and material around it. 30. Earth is protected by its atmosphere and magnetic field. The atmosphere burns up many small incoming objects and blocks harmful radiation. The magnetic field helps deflect charged particles from the Sun. These protections are not perfect, but they are important for the conditions that allow life on Earth's surface. 31. The aurora is caused by charged particles interacting with Earth's atmosphere. These particles are guided by Earth's magnetic field toward polar regions. When they collide with atoms and molecules in the upper atmosphere, light is emitted. Different colors can be produced depending on the gases involved and the altitude of the interaction. 32. Stars have different colors because they have different surface temperatures. Cooler stars tend to appear red or orange. Hotter stars tend to appear white or blue-white. The color of a star gives astronomers useful information about its temperature, though the details require careful measurement. 33. Mass is the most important factor in the life of a star. A star's mass affects its temperature, brightness, lifetime, and eventual fate. Very massive stars burn through their fuel quickly and may end their lives in supernova explosions. Lower mass stars use their fuel more slowly and can live for very long periods. 34. The Sun is expected to remain stable for billions of years. It is currently in the main sequence stage of its life, where it fuses hydrogen into helium in its core. Eventually, the Sun will change as its core fuel is altered. But this process occurs on timescales far longer than human history. 35. A galaxy is a large system of stars, gas, dust, dark matter, and other objects bound together by gravity. Our galaxy is the Milky Way. It contains hundreds of billions of stars, along with nebulae, star clusters, planets, and interstellar material. The Milky Way is only one galaxy among many. 36. The Milky Way is a spiral galaxy. It has a central region and spiral arms containing stars, gas, and dust. The solar system is located in one of the galaxy's smaller spiral structures, far from the galactic center. We are not at the center of the Milky Way. 37. The center of the Milky Way contains a supermassive black hole. It is called Sagittarius, a star. It has a mass of millions of suns. It does not pull in the entire galaxy, because objects orbit it according to gravity and distance, just as planets orbit the sun without immediately falling into it. 38. A black hole is not a cosmic vacuum cleaner. It is an object with gravity so strong that, within a certain boundary called the event horizon, light cannot escape. But from far away, a black hole's gravity behaves like the gravity of any other object with the same mass. If the Sun were replaced by a black hole with the same mass, Earth would continue orbiting in approximately the same path, although Earth would lose sunlight and heat. 39. The event horizon is the boundary beyond which light cannot escape from a black hole. It is not a solid surface. It is a region defined by gravity and escape velocity. Once something crosses the event horizon, according to general relativity, it cannot return to the outside universe. 40. Nebulae are clouds of gas and dust in space. Some nebulae are regions where stars form. Others are the remains of dying stars. Some reflect light from nearby stars, and some emit light because their gas is energized. Nebulae are not all the same kind of object, even though they may look similar in photographs. 41. Stars form inside cold, dense regions of gas and dust. Gravity causes parts of a cloud to collapse. As material gathers, it heats up. If the central region becomes hot and dense enough, nuclear fusion can begin, and a new star is formed. This process can take a very long time. 42. Planets form from material left over around young stars. After a star forms, a disk of gas and dust may remain around it. Small particles collide and stick together. Over time, larger bodies can form. This process is not perfectly efficient, and planetary systems can develop in many different ways. 43. Most of the planets discovered outside our solar system are called exoplanets. Thousands of exoplanets have been confirmed. Some are gas giants close to their stars. Some are rocky worlds. Some orbit in systems very different from ours. The discovery of exoplanets has shown that planets are common in the galaxy. 44. Astronomers often detect exoplanets indirectly. One common method is the transit method. If a planet passes in front of its star from our point of view, the star's brightness dips slightly. Another method is the radial velocity method, which detects tiny movements of a star caused by the gravity of an orbiting planet. 45. The universe is expanding. This means that, on large scales, distant galaxies are moving away from one another as space itself expands. The expansion is not like galaxies flying through pre-existing empty space from a central point. It is better understood as the stretching of space between distant objects. 46. The observable universe is limited by the speed of light and the age of the universe. There may be more universe beyond what we can observe, but light from those regions has not had enough time to reach us. The observable universe is therefore not necessarily the entire universe. It is the part from which light has reached Earth or could reach us in principle. 47. The cosmic microwave background is leftover radiation from the early universe. It is not visible light, but microwave radiation. It comes from a time when the universe became transparent enough for light to travel freely. This radiation is one of the strongest pieces of evidence for the Big Bang model. 48. Dark matter is matter that does not emit, absorb, or reflect light in the usual way. Astronomers infer its presence from its gravitational effects on galaxies, galaxy clusters, and the large-scale structure of the universe. Its exact nature is still unknown. It is called dark not because it is necessarily black, but because it does not interact with light in the ordinary, visible way. 49. Dark energy is the name given to whatever is causing the expansion of the universe to accelerate. It is not well understood. The term describes an observed effect more than a fully explained substance. In modern cosmology, dark energy is one of the largest unresolved questions. 50. Most of the universe is not made of ordinary matter. The atoms that make up stars, planets, dust, gas, and living organisms are only a small part of the total energy and matter content of the universe. Dark matter and dark energy appear to make up most of it, according to current cosmological models. This does not make ordinary matter unimportant. It simply means that the visible universe is only part of the larger physical picture. These 50 facts give only a quiet outline of space. They begin close to Earth with the moon, tides, orbit, and atmosphere. Then they move outward through the planets, comets, meteors, stars, galaxies, black holes, and the large-scale universe. Space is often described in dramatic language, but it does not need dramatic language to be interesting. Its basic facts are already large enough. Distances are large, processes are slow. Stars live for millions or billions of years. Planets move in regular paths. Light travels across empty regions for long periods of time. Galaxies hold vast numbers of stars, and the universe continues to expand on scales that are difficult for the human mind to picture directly. For now, it is enough to understand the subject in a simple and orderly way. Space is not empty. Light has a finite speed. Gravity shapes motion. Stars produce energy. Planets form from disks of material. Galaxies are systems of stars and matter. And the universe, as far as we can observe it, is larger, older, and stranger than ordinary experience suggests. That is the basic scientific picture. Not complete, not final, but calm, structured, and sufficient for this quiet lecture.